microquasars. That is a binary star system. And that means that there's one star and another star, like the Sun, but they are orbiting each other. So not the Sun and the Earth or something and the planet, but two suns are orbiting each other. And here by these microquasars, it seems to be already a very massive star, a neutron star, or even a black hole seems to be. And the other star is also a very big star, a blue supergiant star, or blue star, 10 times as big as the Sun, for example. And now it seems to be sucking in a bit gas from the other star. And that seems to accumulate around as an accretion disk, around the black hole. The book isn't saying if it can be also a neutron star or microquasars. There is something going there from the gases of the other star accumulating a bit. And then like the LMXBs or HMXBs, there is then a bit pulled indirectly and hitting the surface of a white dwarf or even the neutron star or even the black hole. And then this kinetic energy of the gases hitting the surface of it are converted around and emitted as X-rays. I don't know if it's now also happening by black holes, but the neutron stars would be the case. And now these microquasars, where is that happening? But then there's a bit more happening. First, a little story at the side. One, for example, is in the Akea constellation 17,000 kilometers away from the Earth, SS433, where that is happening. And another story. The story is microquasars is the name of this binary system, and quasars, the book is saying that are galaxies, and in the core of a galaxy there is a black hole, and that is also pulling in gases, having an accretion disk around it, and that is also emitting just at a way larger scale as microquasars. So microquasar similar. Now, one other one is the Old Faithful microquasar, and that is named after a glacier in the Yellowstone National Park in North America, because it is pulling in these gases for around 30 minutes, and for around 25 to 30 minutes, I don't know exactly, it is pulling some gases to it, the black hole and neutron star, and converting them to X-rays. So for 25 to 30 minutes or something, for half an hour, it is emitting X-rays. And then, after 30 minutes, also enough has accumulated in the accretion disk around it, and then the accretion disk is doing what it does in nova binary stars or dwarf nova binary stars. The accretion disk by itself gets so massive, heating up, making thermonuclear reaction, it is exploding. Nova is Latin meaning new because sometimes stars suddenly appear through this nova explosion. There is nothing and then suddenly it gets very bright through this explosion and it appears as if a new star was there. It was all the time there, it has just not that much light. Now, and when the accretion disk out of the gases pulled in is igniting, and for a few minutes, for 5 minutes, there is now visible light, because these nova stars were visible, the visible light, and infrared light. And then the accretion disk has burned up again, like in dwarf nova, and it starts again accumulating more, at the same time as something's pulled into the neutron star black hole, converted around the kinetic energy when it hits the surface into X-rays, and for another half an hour it's emitting X-rays. And then again the explosion or igniting of the accretion disk. So these are microquasars. Two binary stars circling, one pulling in, and from time to, it is all the time pulling something in, that is converted into X-rays, and from time to time the accretion disk with the gases around it seems to explode, making then visible light and infrared light. According to Mark A. Garlick's Cosmic Menagerie book on the pages 78 and 79, the positions and views expressed are the ones of the source and not necessarily aligned with our own or with the ones of the entities spoken of.